Hi, good afternoon. Thank you for attending our session. My name is Ming Yuan. I'm a technical architect working for Zurich North America. And today, Dave and we are going to share our journey of building an analytical ecosystem on the cloud. So now turn over to Dave.
Hi, everyone. I'm Dave Carlson. Currently, I'm a solutions architect at Databricks. But formally, and that's what I'm here talking about today, I manage the analytics and engineering team at Zurich North America. So today we will be talking about some of the technical capabilities that have been built out at Zurich, and how they support kind of the end-to-end analytic lifecycle. And Ming will kind of go into some detail around our Metastore, as well as some deployment capabilities that have been built out. So for those that are not familiar with Zurich North America, we're one of the largest commercial property and casualty insurance companies in the U.S., and we're part of the larger global insurance group. So the area that I worked in was called data analytics, and one of the things that we wanted to make sure we could do is really make sure we could bring data-driven decision making to our business. And at Zurich there were three main focus areas that we had. Customers, we wanted to make sure through our data insights, we could help our customers better understand and manage their risk. So the best loss is one that doesn't happen, right? Underwriting, we wanted to make sure we could support and enhance the risk selection process, be able to help our underwriters and our business leads with their program structuring and pricing decisions, both at an account level and also at a portfolio level. And last but not least, claims. We want to make sure we could improve outcomes in the claims handling process. So make sure claims that potentially could develop into more severe claims without proper oversight, we get the right claims professional, maybe you get a nurse practitioner assigned on claims that may develop into more severe risks. And how do we do that? So to the right, you'll see many people have seen some iteration of the analytics lifecycle, from ideation to your actual model build, development, execution, and model monitoring, right? So what are some of the key capabilities that we needed? Because data scientists, what you need is you need some fairly technical capabilities, but at the same time, we're not developers. We're as data scientists, so we want to make sure things that need to be taken care of, but we don't necessarily want to be aware of day-to-day basis, like security, scalability, are taken care of for us. So some of the key capabilities are data discovery. I know what I can analyze and what I can't analyze. Right? I can't analyze what I can't find. So we need to make sure through the tens of thousands of tables that we potentially had access to, that we could easily find and discover the relevant data needed for analysis, and also be able to make sure that once we discovered it, we're actually able to integrate it in a way that we could actually potentially work with data engineers and build it out into something we could actually deploy in a data pipeline. Because previously we had proprietary analysis tools that we do the analysis, and we'd have to extract all the business requirements and deploy it, and that could take potentially up to 2 years. Back in the day, when we use proprietary tools that had to be refactored into other deployable languages. And collaboration. Not all of our data scientists and all of our analysts are co-located in the same office, so we're not on the same city, country, time zone, right? So we need to make sure that we had a tool set that we could encourage collaboration on projects, on multi-person teams, not only multi-person teams, but also multi-persona teams, right? So we might have business analysts, data engineers, data scientists, actuaries, all wanting to, contribute and understand, the source of the data, what transformations are being done, are they being done appropriately, being able to try out new features, and integrate them quickly, right? So, that was one of our kind of requirements as we were building out this ecosystem of tools and overall analytics landscape. And definitely not least business impact. We want to make sure that we could severely decrease the speed to market, right? So we wanted to make sure that our data discovery tools integrate with our integration standpoint. To the extent if our data scientists want to use common data set science frameworks, in Python and R, we could easily connect all of those together and chain them in deployable pipelines. And and related to that is multiple types of implementation. Sometimes we might be building something to integrate into a calling application, so we might have to build like a REST API. Other times, it was fine for the business to know like the next day or maybe once a week. If it's something where it's a triage or a workflow type thing, we didn't necessarily need to know that instance. And batch generally was easier and quicker to build and deploy over real-time integrations. And also, scalability. Scalability, can mean different things to different people. We need to make sure from an analysis standpoint, we were using tools that allowed us to scale up, or scale out an analysis. Like the days of having data sets that, would fit and work on your local desktop or laptop, generally that isn't the case in, enterprise settings. So we needed to make sure we could definitely easily scale up, scale out, our compute needs. And also from a people perspective, we need to make sure that we definitely preferred server-side web-based tools, so that way we don't have to worry about an enterprise setting. Your environment, your client environments might be locked down, so we needed to make sure that we had tools that could scale out to a fairly large user base. And then deployments, we need to make sure that we were using tools that we could actually take the work that was done by our data engineers or data scientists and be able to quickly move that to a deployment ecosystem. And now I'm going to kind of hand it over to Ming, and Ming is going to kind of go into detail around like some of our data discovery and integration type capabilities.
Thanks, Dave. So let's talk about the data foundation. To us, data foundation doesn't just mean the bytes on disk. Data scientists need a powerful platform where data can be stored, transformed, and analyzed. On the slide, here are a few use cases of the data platform. First of all, the platform should allow data scientists to apply mathematical algorithms to the data and generate insights. Those insights will in turn help Zurich and our customers to make better business decisions and drive business impact. After being curated, the data can serve for many purposes. The platform should also provide an avenue for business users to explore data, for data analysts to find hidden patterns, and for the reporting analysts to create BI reports. The definition of analyzable data has changed from the corporate tabular format to all kinds, structured, semi-structured, or even unstructured. The platform should allow users to mash them up together and make sense of them. Other use cases include optimizing operational cost and support security and governance processes. In response to those use cases, Zurich has implemented a data lake on Azure cloud. The lake concept has been around for a while. Using cloud services, our lake is not only the simple storage place, but also offer plenty of processing power. We divided the physical storage into separate layers. Just like water, data flows through those layers and gets purified for the consumer. The layered design aims to meet different needs from different groups. Each layer is a dedicated network location, and the data files are further organized into folder structure by subject area, source system, and the timestamps. Spark cluster is the computation engine pushing data through those layers. The cloud provides multiple options to economically implement a data lake architecture. We store data files on Azure ADLS and use Databricks PaaS offering. ETL pipelines are managed by an in-house developed framework. Currently, our data lake platform has more than 900 terabytes of data and performs more than 40,000 transformation tasks each day. And those numbers are still growing. The next topic is about metadata. Metadata is a shorthand representation of the data. It makes finding and working with instances of data easier. Considering the size and the complexity of our data lake, a platform supporting metadata management became critical. We defined an admin role to collect and manage metadata entries on the platform. The other end of a platform is the user. They use the platform to search, view, use, and share metadata. We expect our metadata management platform to facilitate all of those functions. After carefully evaluating several data catalog products, we chose Alation as the metadata management platform. Using the built-in connectors, we quickly integrated Alation with the data lake, plus 18 on-prem data repositories. The synchronization with source systems are automated and managed by Alation, so that metadata changes in those sources can be rapidly reflected. Currently, our Alation platform has more than 2 million metadata records covering 1.5 petabytes of data. Alation's UI is easy to use. Metadata info is well organized in web pages. We have enabled the social collaboration features such as Google search, endorsement, object watching, and alerting. A built-in SQL editor would allow data scientists to quickly test ad hoc SQL queries against any source system. All these front-end functions makes the data catalog a self-service portal of the entire data ecosystem. Now I'm turning to Dave to talk about the next platform.
Thanks, Ming. So as Ming kind of talked about our data discovery, we wanted to make sure, as we we're looking through our data catalog, and our data scientists, analysts, found additional information about a given data source, be able to contribute that back, but also then be able to pull that into an overall ETL pipeline, and for training as well as for scoring, right? And the way that we did that, we leveraged multiple tools, which kind of have a flow we'll kind of go over in a bit. But we wanted to make sure that we eliminated a lot of the silos that we had historically, where our data analysts might want to use a SQL-based tool, or people who really wanted to use R, would use our Studio, or we would have people that maybe had a smaller data set and they want to use Python, they might just be using local Jupyter. Well, what would happen is on larger projects we would have different portions being worked out and analyzed separately. They might copy over the resulting data sets, and integrate them together. but we kind of lost potentially on some projects, that full end-to-end on, at least from an ease of integration, right? So, to the extent if we had to like stitch this into a common pipeline, we had to once again refactor all of that into a common pipeline, which really slowed down and had tremendous impact on our speed to market. So, we wanted to make sure that we really could, help, those multiple personas that we talked about before, really work together and integrate into an overall, pipeline. So this is just like a really high level, view and flow of, that hopefully one thing you got out of this is like, the integration. Like we needed to easily facilitate, the integration of various data sources. Like as being said, we had a cloud data lake, but we still had a lot of on-prem historic, data sources that, maybe they're Netezza, maybe they're Microsoft SQL, Postgres, what have you. And we didn't want to have our data scientists, be, wasting cycles on tracking down, not only the right drivers, but also the right credentials. I'm sure this, only happened, at Zurich. Everyone's done it where, they accidentally maybe put secrets into like a code repository or something like that. We wanted to make sure that the right way was the easy way, right? So, we leverage as our front end integration tool, Dataiku, and that kind of allowed, people who wanted to work with like a codeless, code light type environment, or maybe even SQL or R, push, scale of computation out to a Spark layer. Allowed us to build that out in a way that we capture all those business rules, but we also were able to then take that and bundle it and test and push it out to production. And our timelines went down from tens of months to a matter of months, which compared to what we were used to, was huge to our business, and also helped us support like the multiple type of deployment where to do the initial business impact, you might do a more simple deployment, batch deployment, and then work on maybe the more robust or the the real time type deployment solution. And as far as like other options of deployment, Ming is now going to be covering that through our use of containerization and CI/CD processes.
Thanks, Dave. Let's switch gears to model deployment with containers. Containerization is a lightweight virtualization mechanism. A container can be easily created from a manifest file and precisely encapsulate the application with its own runtime environment. Containers helps model applications to reduce the system footprint and resolve potential conflicts between machine learning libraries. The container platform also naturally supports elasticity. The container platform also naturally supports elasticity. The instances can be rapidly provisioned or deprovisioned to adapt to the workload changes. This is really useful to economically maintain the right system capacity. Containers are immutable packages and can run virtually anywhere. So we can easily migrate a containerized application from development to QA to prod. Along with the container, we often heard microservices. This term refers to an architectural style, a set of small services communicate with lightweight mechanisms. Each service runs in its own process and can be independently deployed and tested. Containerization and cloud services naturally support this architecture. We see microservices as a good fit to implement scoring engine APIs, as Dave mentioned before. The diagram on the slide is our reference architecture, where we tied microservices, containers, and the cloud together. DevOps is a methodology where development team and ops teams work closely from design to development to production support. This collaborative approach promotes the productivity so that IT teams build, test, and release software faster and more reliable. While working on our data platforms, we have successfully introduced the DevOps principles to the field of data and analytics. The data scientists and IT teams start collaborating as soon as a new project kicks off. Push button deployment enable us to iteratively release new versions. And even business users can also participate in the process. They could test and give feedback right after each release. This short feedback loop helped not only the data scientists to adjust model definitions, but also business users to understand and predict the business impact. To support DevOps processes, we integrate a set of tools with other platforms. The diagram depicts a sample pipelines commonly used across our projects. When a new modeling project begins, such pipelines along with system components will be created. Data scientists, developers, ops engineers can then use those tools to collaborate during the course of the whole model development lifecycle. To summarize, we started our journey with streamlining the phases in the model development lifecycle and defining main use cases at each phase. Those use cases drove the requirements to build the analytical ecosystem. We evaluated many analytics tools on the market. We found each of them has its own strengths, priorities, and vision. However, we have only selectively adopted the platforms that meet our requirements, align with our processes, and match with our skill set. But more importantly, we paid a great attention to integrating individual projects into a holistic ecosystem. Data science, AI, and machine learning are the fields evolving really quickly. We are open to ride the new waves and continuously improve the technical landscape and our current processes. With that, we conclude our presentation.